It started October.
All right. So let me share my screen. All right. Hello, everyone. How are you? Everyone good? So again, the rule is the same. If you have any question or comments, feedback, feel free to type it in a chat, and Nikhil will try to inform me about any important or any chats messages to me. Okay. So today the second part is machine learning algorithms. So again, this is like myself, June Young Park. I'm assistant professor at UTA to teach the civil engineering topics about the smart buildings and smart cities. So yesterday, we briefly talking about the ML, the introduction to ML. So we discussed the general objective of this bootcamp and also what is machine learning, and we briefly talking about the definition of machine learning and some key concepts to machine learning algorithm development, for example, cross-validation and confusion matrices. And just to recap, the objective of the bootcamp is this is not a the complete or comprehensive course to understand the whole ML, but this is a gentle introduction that you are knowing some terminologies and make you guys kind of interest in ML so that you can start your own learning on this machine learning topic. And yeah, so feel free to use like today's contents as well as like kind of the bridging yourself to the ML word. Um, today's like right now the lecture is the content 2, ML algorithms. So there'll be three main parts: supervised learning, unsupervised learning, and reinforcement learning. And supervised learning, there are a bunch of like supervised learning algorithms, but we'll focus on decision tree and nearest neighborhood. And unsupervised learning, k-means clustering, and reinforcement learning, one of the key components of reinforcement learning, which is Markov decision processes. So like I introduced or like I discussed yesterday, there are many algorithms, but I choose those simple and basic algorithms today because those are the starting point of understanding those three components of supervised, unsupervised, and reinforcement learning. And I mean, having the basic and prior knowledge on those components, then it'll be like, again, good the bridges to the whole words of the different algorithms. And once we complete the ML algorithms, then we'll go to the coding practice for ML as a lecture content 3. So we'll use the building energy data for learning classification algorithms that we covered in just right now lecture, how to implement the KNN and decision tree using the building energy data set itself. And refer back to the very introductory slide of yesterday. One of the best way to learn the machine learning is using the real world data set and having the this bootcamp, the major focus is either energy or water resource. The building energy data, utilizing building energy data will be like kind of accessible or friendly to utilizing your like prior knowledge or the domain knowledge of energy to learn the ML. So let's get started about the supervised, unsupervised, and reinforcement learning. So like I said, there are three classification, mainly two classification, but I put reinforcement learning in here. So the supervised learning is the learning mapping from input to output, and that can be classification or the regression. The main difference between supervised and unsupervised learning is in a supervised learning algorithms, you have labels, which is outputs, and then you are linking or the mapping between those inputs data and the label. On the other hand, the unsupervised learning is you just receive the inputs and learn the patterns of those input data. So one example here is a clustering. So you see how the data distributed, and then you clustered or grouping your data points based on the patterns of their distribution. And reinforcement learning is somehow using both supervised and unsupervised learning. It starts from the unsupervised learning, but it gets the outputs or labels from the environment, getting the reward or penalty from the system. So you are learning to act from the rewards from the absence of the examples. So that is kind of how robot walks, or how um, the game of Go playing. So it's more on decision-making processes on like input data and then getting the reward and feedback on your new movement. Keep iterating this loop, then ultimately you are learning the optimal decision-making processes. So that's the three main the classification of ML algorithms. So supervised learning is modeling the relationship between measured features of data and some label associated with the data. Once this model is determined, it can be used to apply labels to new unknown data. So what it means is last lecture we learned about the features. So features like we discussed yesterday, you have a raw data, and then you are extracting the informative like features that you can extract from the data. So the example that I showed you like yesterday was there's an image, and then you extract the RGB, the numbers, and then making a mean value, or just playing with those RGB numbers to make the what is the most representative, the number or features that you can extract. Another feature that I introduced yesterday was there's a building energy profiles, and the importance of the building energy profile is when is the peak and what is the peak. So you can just simplify those numeric values into like 4 letters, for example. So like once you get those features, now you are having those features with your own label. So like the example of that ABCA or ACCA, the building energy profile, then you can say, oh, ACCA is a very typical day, or like AAAAA, and it's no energy consumption day. So like holiday events, I don't know. So you can make a labels on it. And once you get the features and label, then now you can extract the rule or mapping of those two. And once your new data comes in, then you can return the output, the new labels out of whatever you learned, trained model and the input data. So that's the supervised learning. To another classification or another types of supervised learning, one is a classification and the other is regression. Can anyone differentiate between classification and regression? Let's go to chat. Can anyone try? What is the difference between classification and regression? Just try. All right, so let's see. Classification is determining what data set goes where. Regression is determining how the data is related to itself. Classification not to follow the trend line while regression does. Okay, looks like there's a different markers. Okay, there's a lot of typos. That's a lot of typos. That's okay. I can understand. So the you can think of two ways. Um, Classification is for the classical values or the types labels. For example, if you want to determine like there's the model that determine what is the um like fruit type. So like the previous example was you show the camera and then the model determine either it's lime or orange. So it's two categorical values, right? Either it is orange or lime. So if it's a categorical labels, then it's classification. On the other hand, regression is more on numerical values. So if you want to predict um, the tomorrow's like the like water, I mean the rate of the rain tomorrow, or prediction of tomorrow, like how much water will come. I mean, rainfall will come in tomorrow. That's a numeric value, either like 0, 1, 2, 3, 4, those numeric values. Then it is the regression. Like like what is the chance of rain tomorrow? Those kind of thing is more on regression. On the other hand, the classification is like if you have a categorical like classifying things, then it's a classification. So both are supervised learning because in classification algorithm, you need the classified values. Either it's a lime or orange. So it's a obviously supervised learning. And regression value is if you have a given conditions, then tomorrow it will rain this much. So that is a number associated, or number outputs associated. So it'll be the regression. And you often convert the regression problem into the classification problem. For example, the chance of rain is higher than 50% or less than 50%. So it's not anymore just a regression problem, just a two binary set of the classification problem too. But anyway, the the very fundamental starting point of the supervised learning is either classification and regression. And classification is like classifying the categorical value, and regression is the numeric, the regress values that you want to know. That's the regression. Any question on classification and regression? All right. So the supervised learning that I'm going to introduce is K nearest neighborhood algorithm. We normally say KNN algorithm. So suppose we have a known value, which is a blue dot, and you are checking, and then you are giving, hey, I want to check the three neighbors. And around that blue unknown dot, you are checking the three nearest neighbors, which is this white on your left top and the orange on your right and on your right below. And you check you know, three candidates or three neighbors, and which which like class number is more, which is more frequent, or which is more classified values? Is it white or orange? Is it white or orange? Orange, yes. It's orange, yes. So there is a one white and two orange values. So the intuition here is, okay, so this is likely that blue unknown value follows the classification of the orange, which is a class one. So the K equal 3 KNN algorithm on your input unknown data is, you can label it as orange label, class one. Okay, so that's the starting point. Oops. So the main idea for KNN is in a data set of example x comma y, given input xi, you are checking your neighbors, k neighbors. The previous example was k equal 3, but you can choose k equal 5, k equal 10, k equal 11, and so on. So for example, um, so let me do it this way. Hey, Nikhil, so everyone, Nikhil, can you see my like circle
Yes.
in my, okay.
Yes.
So, okay. Thank you. So let me make no fill. Then line has white line. All right. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's a tie. So let me make it smaller. Oops. Shape. 5, 5. Four. Oops. So let's say I'm going to do k equal 5, not 3. Then what would be my label? If I do k equal 5, what would be my label? Still orange? Why? Anyway, why? Why it's, yeah,
Uh,
James, why?
because there's 3 orange dots in the k equal 5 and only 2 white dots.
Yeah, exactly. So that's how you can do it. And one mistakes, or not it's mistakes, but not good example was I made a like kind of 10, k equal 10, and there's equal 5 to 5. So 5 orange and 5 like white. So if you choose the even number of your k, then there's some chance that you'll get the like the equal things going on. So normally people choose the odd number so that you can have the absolute winner of your classification. If it's a 4, then 2 by 2, like kind of tied. So it's, it's better to make a k equal odd number so you can have a absolute classification out of it. So find the k examples that are nearest to your input data and use this k example for classification and use a measured class of the k neighbors. So now the question is, what are good values for k? So the first example, I choose 3 and 5 and 10. So we don't know. We have to choose the right k number. So this is the K9 classification for earthquake. So there's a two, the wave values x1 and x2. And then you put that things, and then all the black labeled is those like kind of shaking by nuclear explosion. And the white label is literally earthquake. And then you can see some like decision boundary on those earthquake and nuclear explosion. And if you choose k equal 1, then the decision boundary will be looking like this, which means the kind of shaded or grayed area, if the dots are located in those shaded area, then they are classified as a nuclear explosion. And if it's a white, then classified as earthquakes. If you choose k equal 5, then the decision boundary is a lot simpler. Okay? Now it goes to how to choose a K. And it goes to the previous or the yesterday lecture about the underfitting and overfitting issue. Is it high K or low K? What is a problem related to the underfitting and overfitting issue? So let's see in detail. If you put the low K, like this example, K equal 1, then it perfectly classifies all existing data points. But some points can be outliers or noisy. So for example, you're only checking the nearest neighbor, just one. Then if the one neighbor has the labels by some outliers or noisy or some wrong labeled, then you are somehow the overfit of the problems. So it goes to the lines that we draw on those age and income value. And as you can see, decision boundary is very complex. On the other hand, the underfitting problem will be happen by higher k number. So if you put like 100 or 1000 k, then the decision boundary will be very simple, and everything will be classified as the most frequent class in the whole data set. So for example, of this earthquake problem, most of data set will be classified as an earthquake if you check 100 or 10 or 100 or thousands of neighbor. So it might lead to the underfitting problem with the very simple decision boundary like this. How to avoid such problem? Again, we need to use a cross-validation with the varying king and choose k with the lowest cross-validation error. Do you remember cross-validation? So the cross-validation is the main idea is split and repeat. You make a chunk of your data set into 10 different chunks and then keep repeating your chunk, like changing your training and testing data set, and then see the average, the error or average accuracy value on your data set, which will give you more generalized and more um, conventional approach on the model. Okay. So any question on this overfitting and underfitting related to the K value? You good? All right. So again, if it's a low K, then it'll be overfitting. It's very complex decision boundary. And if it's a higher K, then everything will be classified the most frequent class, and it's underfitting problem with the very simple decision boundary. So again, we need to use a cross validation to choose the right K. And there's an issue related to cursive dimensionality. So KNN works well in low dimensional space with the plenty of data. So for example, this earthquake problem is only two-dimensional space. But if we add the third dimensional and n-dimensional space, then your neighbor is really, really far away from you. So, which is not very informative. So if your data set has more than like 15 features or 15 dimensions, then maybe K-nearest neighborhood algorithm is not the suitable choice. And if your like data set is very small, then it's not a good idea. So this is the moment that you need to choose or try to use a KNN. First, the dimension is less than 15 and have more data or large data points. Then the KNN works pretty well, and it's a simple and elegant algorithm. Any question? Okay, here's some example in using KNN for the building related problem. So there's a small like Raspberry Pi based like moving robot, and then that robot goes around the room like your like robot the vacuum cleaning, and then it checks the temperature value and relative humidity and all the thermal environment and also the air quality indexes around the room. And then it keep asking the people, hey, do you feel cold? Do you feel hot? Within that 7 different scales. So which is a labeling. And then it makes a boundary of the spaces using the relative humidity and the air temperature. So like very similar to the earthquake problem. The X1 is relative humidity and X2 is air temperature. And depending on your relative humidity and air temperature, people gives you the labels about the either hot or cold. And then you can find the decision boundary based on the K nearest the neighborhood, both for cooling and heating season. So again, the KNN will work pretty well when it's like less dimensional space and large data points like this case. All right. Any question on KNN? Okay, let's move on. So next one is a decision tree. And decision tree itself is we are experiencing this decision tree all the time, like in biology class, or sometimes you make this decision tree like finding out what is your best like food or best sports team or those kind of meme. So here, like it asks, is it a mammal? Yes or no? Do people commonly keep it as a pet? Yes or no? And hamster, goat, an elephant, squid, spider. So keep asking those questions and then you are ended up with your class 5. So is decision tree this kind of algorithm is, I mean, if I'm just showing this like decision tree to you, is this classification or regression? Oh, classification, yes, because it's categorical value, not numerical value. Yes. Right, you're right. Okay, I got the one question from Emmanuel. And why does a high value of K lead to underfitting in KNN? Okay, so let's go back. So Emmanuel, if the higher K values, then let's go to this example. Um, if I insert shape, let's say you're checking like our insert K equal, I don't know, let's made it up, K equal 50. and your input data is this, like the middle one, then you are basically count all the data points here and then pick the majority, which is the white label, which is earthquake, right? So if you're having higher K number, then you're always going into the most frequent label. And that is underfitting problem because like you see here, your decision boundary will be very, very simple. And you just follow the earthquake. You don't need to check anything because you're just following falls into the problem or the dilemma of the majority or the most frequent. So again, simple question here is everything will be classified as the most frequent class in the whole data set, which results in the underfitting problem because it's not like it falls into the bias issue. Emmanuel, does it make sense to you?
Yes, that's better. Thank you.
Uh, All right, thanks for your question. Okay, let's move on. So, main idea about the decision tree, as you saw here, to figure out which features are the most informative one to ask. So, now the key thing about the decision tree is what kind of question you should ask. So the very first question it asks is it a mammal, right? Because you ask this question, you are classifying the things into three, which is a hamster, goat, elephant, and another two, squid and spider. So the question is very important. And what is the most informative question? Choosing that informative question is the most important thing, considerations in the decision tree algorithms. How the domain is split up after the answer is received, and the likelihood of each of the answers. That's the main idea. And decision tree consists of a root node, interior node, and leaf nodes. Each of the non-leaf nodes in the tree specifies a test to be carried out on one of the query's descriptive features. Each of the leaf nodes specifies a predicted classification for the query. All right, let's move on. So there's a decision tree, and you want to like classify those for people, Brian, John, Afara, and Alfie. And there's a man, yes, yes, no, no. I mean, the Brian is yes, he's a man. No, he's short hair. Glasses, yes. John is yes, no, no, and so on. So, what would be your first question? Is it a man or does the person wear glasses? So if you ask, is it a man? Then the two main kind of classification here is Brian and John and Afara and Alfie. And if you ask, does the person wear glasses? Then only one side, Brian, and the other three people. So from the informative gain perspective, is it a man question is more informative question you should ask at the very first. So let's see. If you ask, like, does the person wear glasses? Yes, Brian. No, those three people. And the next question is it a man? Yes or no? And do they have long hair? Yes or no? And you are basically average the number of questions. So one question and two questions and three questions and three questions divide by four. And two questions and two questions and two questions and divide by four. So the very first choice of is it a man versus does the person wear glasses will result in the number of questions that you can ask. So it's obvious that asking the questions that like splitting the data set into the half is the most effective way. So we're choosing the is it a man question as the first question. And we can apply this decision tree in building energy domain again. And there's a one paper talking about, hey, can we ask those decision tree questions to cluster or to characterize the building types of the energy consumption? And you can do that class characterization of the buildings by decision tree algorithms, of course. And that questions is temperature is high, or what is your HVAC type, and what is your EUI, energy use intensity, those kind of questions. You can classify them. And again, this is not the complete list of all the supervised learning algorithms, but like for example, using the decision tree, you can apply it to the random forest algorithm. And there's a support vector machine algorithm, and there's a logistic regression algorithm, and there's a linear regression algorithm. And I guess most of you guys heard about the linear regression or even worked with the linear regression before. And Bayes and using the Bayesian assumption. And there's an artificial neural network, ANN, which is quite powerful. And like again, because of this neural network algorithm, all the new advanced supervised learning is evolved these days. So it is important to note that the two algorithms that I introduced today is very, very, very just a starting point, but there's a whole new world on those supervised learning algorithms, and it's your own call to choose or one or two algorithms in here and check out the YouTube video or different lectures so that you are jumping into the different fields of the supervised learning algorithms. Okay, so let's move on to unsupervised learning. So compared to the supervised learning, unsupervised learning is modeling the features of a data set without reference to any label. It is often described as letting the data set speak for itself. So let's say you are having a lot of students here and you ask questions and you can group those students by seeing the answering patterns. So for example, hey, what is your favorite movie in which is published in 2000 years? Or what is your favorite movie? Or what is your favorite drama? Or what is your favorite music? And by seeing those like answers of these people, then you can cluster or you can group the people by their characteristics or their personality. So another way of saying this unsupervised learning is when we are learning to see, nobody telling us what their right answers are. Instead, we just look. So that means we just see the data set itself, and then we can classify or we can cluster those data set into our own observation. So that's the another way of expressing the unsupervised learning. And when we cluster the observation of a data set, we seek to partition them into the distinct groups so that the observation within each group are quite similar to each other, while observation in different groups are quite different from each other. No need for data label. It just, we don't need to data label. We don't need to put the personality by, oh, this person likes the romantic or the action oriented, but you're just knowing that thing by seeing the answers by the favorite movie, favorite music, favorite drama. But challenges here. No simple goal for the analysis such as a prediction. So it is very vague somehow depending upon how you view those data set. And number two, it is hard to assess the results since there's no labels, there's no accuracy associated with the unsupervised learning. So those two challenges on unsupervised learning itself, but it is more on the seeing the input data and see the pattern and cluster the data points. So here's the thing. you have the original unclustered data set, which is on your left side. And then you can, if someone say, hey, I want to cluster these original blue data set blue points into three different groups, then one can make these like green area and another blue area and red area. So you can just seeing the data and see the patterns, and then you can group or you can cluster those data points by seeing it. And one big famous algorithm of unsupervised learning is k-means clustering. It's a simple and elegant and partitions as a dataset into k distinct and non-overlapping clusters. And to perform the k-means clustering, we must first specify the desired number of cluster k. K equal 3, like the previous example. K equal 2, K equal 5, K equal 10. Then the algorithm will assign each observation to exactly one of the K clusters. And how to choose K? There's no single right answer. You don't know what is the optimal number of K, but sometimes it's also problem dependent. For example, hey, I think my data set will include three different clusters. Somehow they're action or sci-fi or romantic movies. So I just want to three. I'm not sure what is that three, but I just wanted to make, grouping that into three. So like I said, that is one of the challenge. It's rather vague. It requires the domain knowledge of the data analyst and analyst itself. And some in the indices attempt to capture the quality of clustering. For example, you are checking the sum of the squared error and finding out the elbow method. So it keep decreasing the squared error, but if it has too many clusters, then there's no point of clustering. We don't need to cluster that anymore. So we need to find the balance spot like this cake or three. So like our arm shape, it looks like elbow. So cake or three is our elbow method. So here's an example of unsupervised learning. Maybe it's better to having the example to understand the unsupervised learning. There are many buildings out there, and then we want to cluster the building energy profiles of it. So let's say there's a thousands and thousands of building and creates the building load profile. And if we cluster the typical building load profile, then there's a C1, which is a decreasing in the morning and increasing the evening. And maybe this is more like your house. And C2, which is the higher peak during the like around the noon time, and then go down during the evening, which will be some office building look like. And C3 going up a little bit and going down during the nighttime. And we can try, so in this paper, the unsupervised learning approach was applied. One is a k-means clustering, and the other is bisecting k-means and Gaussian multimodal model, GMM model, and then identify what is the best way of the classifying or clustering those profiles to like grasping the concept of different building load profiles. So here's the thing, instead of clustering the buildings or grouping the buildings based on their types, like for example, it's a family house, dormitory, or college lab, or community center, but let's grouping the buildings by their profile shapes. That's the main idea of the using the unsupervised learning approach for the building energy profiles. So again, unsupervised learning is you having the get data input and see the patterns of it and then cluster those patterns. And again, there are many other algorithms you can check it out, including the k-means and bisecting k-means and dbScan method and many more. The important here is more of what is the details of those method, but what is unsupervised learning and what is the difference between unsupervised learning and supervised learning? So supervised learning here means it requires a label and identify the relationship between the label and input. On the other hand, unsupervised learning is more on you have an input and you see the patterns of input and identify the the patterns of input to cluster those input data. Right. I was quite rushing because I realized that the time is ticking. So let's go to the last piece of the three types of machine learning models, which is a reinforcement learning model. And reinforcement learning might be considered to encompass all of artificial intelligence. An agent is placed in an environment and must learn to behave successfully. In many complex domains, RL is the only feasible way to train a program to perform at high levels. So here's a conceptual like descriptions of those models. And supervised learning, like I said, it has labels or target or teacher. So having that labels, the output file, then you are trying to having that error to make your input file having better. And unsupervised learning, it only has an input and it gives your output. There's no such label thing comes into play. On the other hand, the reinforcement learning is somehow mixture with the supervised and unsupervised learning. It is the same thing. You got an input and you got the reward based on your choice of your performance evaluation. If your choice is good, then here the label. Your choice is good, then you got the positive reward. If your action is wrong, then you get the negative penalty. So that having those reward and penalty, you are doing the right decision right after that. So like I said, there's an agent. The agent do an action to the environment and it gets the reward and state and do action again and reward the state. Keep iterating this loop, then agent will do the right decision. There's a Pavlov's experiment about your dog feeding. So you have a dog, and whenever you ring a bell and then give the food, then if you repeat this kind of habits to the dog, then you just ring a bell and the dog start to savory because the dog knows that, oh, there will be food coming in, so let's try to eat. Similarly, we can apply the reinforcement learning in the built environment. So let's say we make a like intelligent agent in a building or cities, and then if we are giving the right signals to the those
So,
agent.
Park,
So if
there is a
yes,
question. Sorry to interrupt. There's a
no, you good.
question in the chat.
Okay, let me check it. So does supervised learning have a target teacher then guides the learning for the model and reinforced is the based on the positive reward or punishment? So this is good question, Nair. And the supervised learning, you have a label, exact the target label that you have. So for example, um, you're having the input and output, the labels on your based on your input. On the other hand, the reinforcement learning is the label is not the existence over there, but it's more on your reward from the environment. So I would say the label is more dynamic and more unknown and like live, I would say, compared to supervised learning. So it can be positive reward or negative punishment. On the other hand, the supervised learning is just the label that, oh, this is good or bad. That's all. But the reinforcement learning is it's more dynamic nature of your reward and the penalty signal. Thanks for the good question. Okay. So the reinforcement learning is the formalized by Markov decision process, which is the formulation of the mathematical formulation of decision-making process. So again, the agent do an action and get a state and reward, and then based on the state and reward, do another action and keep iterating this loop, try and error, then it will ultimately adapt to the environment. So back in 2016, Google DeepMind released the AlphaGo, which is playing the game of Go. And at the very beginning, this like agent, reinforcement learning agent, has no prior knowledge about the game of Go, but it goes to the web game interface and play with several people, and it keep trying a new actions and learn the rules by having the winning the game and losing the game and winning the game and losing the game. If it repeats all the time every day and every night, then it finally win the human champion. So that's the main idea of the reinforcement learning. So to understand the reinforcement learning, we have to understand the Markov decision process. So Markov decision process is, again, the mathematical formation of your decision-making process. Suppose that you have a car, and that car has a three state. One is a good shape, and the other is not good shape, and the last one is a broken shape. So you have a three state. And then depending upon your state, you can choose two different actions. Either you maintain or ignore. So in your good shape, you can go to the maintain shop or ignore your conditions. If you're deteriorating state, you can go to the maintenance shop or ignore it. If your car is broken, you can go to the maintenance shop or you just ignore it. There's the two actions. And then you have a reward based on those, your action selection. So if your car is a good shape, and if you go to the maintenance shop, the cost associated with the maintenance shop is just less, just -1. But if you ignore it, then there's no cost associated. Same thing for the not good condition, but in the broken state, you can either choose go to maintenance shop -2. If you ignore it, then you will ultimately have more money. And if you go to the repair shop from the broken state, then you should spend more money. So -10. Then there's a transition probability from a state to the other state, like 0.96, 0.99, go to the maintenance shop or ignore it. And the transition probability is within the from certain state to the other state based on your action selection. So as a car owner point of view, you're as a RL agent, your objective in here is you want to maintain your car condition as good as possible with the minimum cost expense. That means you maximize the expected future reward. So maximize the expected future reward here means you want to test it out all the possible like scenarios that you can do on the planning, the car planning, and then you want to pick the best policy that you can choose, right? In certain state, I need to choose this. It's like our own strategy too. So in RL point of view, reinforcement learning point of view, once you define the state and action and reward and transition probability, then solve this Markov decision process. MDP means you're having the best optimal policy to maximize the expected future reward. So let's see with an example. So again, here's a building example, which is a light learn. And its light learn is reinforcement learning for building control, especially for the lighting. So in this paper, we put some soft robotics. So this soft robotic here means this case inside, there's a Raspberry Pi, and inside the Raspberry Pi, there's a reinforcement learning agent, and it receives the signals from this lux meter. The lux meter is the illumination value, how bright and how dark it is. And it also checks the time, and it also checks it either is it turning on or off. And then people just use the light switch as usual, and then LightLearn will ultimately finding out the adaptive set points to save energy consumption uh, while the maintaining the comfort level of the people. So very simple intuition here is if the automatic decision by the LightLearn, hey, the agent, the smart building agent itself decide to turn off the light, then if the person doesn't like it, then he or she will stand up and then go to the light switch and override the automatic decision of the turning off. And from the smart building perspective, that is punishment because it did some automatic action, but that was wrong decision. So it got the penalty. So the next time, if the similar situation going on, it will not do that kind of automatic decision, automatic turning off, but staying on the on. If you keep repeating interaction between your smart building agent and the person yourself and keep interacting between these two, then using the reinforcement learning, solving the MDP problem, the smart agent will ultimately finding out the ideal solution or ideal policy, building control strategy for you. That's the main idea of the LightLearn. To make it happen, it is important to, like I said, what is a state, what is an action, what is a reward, which is the MDP property. So first, state and action space design. What is a state and action in this lighting control problem? So this room, like one person's room can be like defined as either occupied or unoccupied. Occupied is someone occupied a space, and unoccupied is empty space. And to make this happen, the LightLearn, the smart building, the agent, is checking the Bluetooth signal of the person in this room and then identify someone is occupied or unoccupied. And the next consideration as a state is on and off. Is the current room is turning on or turned off? And last one is by the light sensor, is the room dark or comfortable level or bright level? And if it's unoccupied, then we don't need to taking into account the is it dark, comfort, bright. And last consideration is what is a period of day? Is it sunrise period or noontime period or sunset period, or is it completely dark period? Having this 26 different episodic states, then we can like describe one day with 26 different episodic states. Note that building control problem is not a like rocket science. We are not really every millisecond like problem. We're not interested in every second problem. What we consider in the building control problem is whenever a person feel the change. I feel my cold, I feel my hot, or I feel my dark, I feel my bright. That is not every millisecond change. We're not that sensitive at all. It is more on the episodic states changes. Then we'll give the penalty term when the occupant's in a discomfort or it's a energy wasting situation, and giving the neutral term for the energy consumption for the comfort. I mean, some energy consumption is good if it is driving the comfort. And we could give the reward, the positive reward, when occupants in a comfort mode or energy saving mode. Then valuation is one of the solving MDP method. So once we define all the state action reward, then we can solve this MDP problem using the valuation method. So here's the thing. There is an optimal path for maximum cumulative reward that to maximize the cumulative reward. For example, the room was completely unoccupied and turned off, which is S18 state at 9:29 a.m. And then it's occupied with the somebody in and the light switch was off and it was a bright condition, which is S15 state. Then the person goes out the room, so it goes to S18 state. And person comes into the room and it goes to S14 state, which is a comfort, switches was off and unoccupied state. So when this state comes in from the reinforcement learning point of view, it can either turning on the light or automatic turn on, or just turning off the light, just waiting for the natural bright or natural light from the outside. And it decides the latter one. But in reality, there's a cloud cover going on, and then the room was more dark again, which is S13 state. From the value point of view, it goes to the negative reward value. So because that was the occupant in a discomfort mode. So it immediately turning on the light goes to S16 state. And then that person just left the room without turning off the light. Which that situation was S19. And this is energy wasting situation, which is minus 0.9. So it immediately turns off the light to go to the positive reward state. And it kind of repeating similar things, decision-making process from the smart building point of view. So more important thing here is you can see from the light learn perspective, it just plays the game with the occupants by interacting by automatic decisions. When you play the Atari game, your joystick is either left side or right side. But from the light learn perspective, his joystick is turning on the light or off the light. And by choosing those turning on the light, off the light, it's like seeing the the, the reaction from the occupants and identify what is the best way of playing the game against the human agent and then finding out the right decision, like just playing the game. So this is 1 day cycle. If every day cycle cumulative, then the smart building agent, reinforcement learning based smart building agent will finding out what is the optimal strategy to play this game. So we implement this light learn approach in 5 different offices in one office building in Austin. And compared to full operation, which is 9 a.m. to 5 p.m., then it saves 82% of energy consumption. And occupancy based, which is whenever you go to the restroom, you swing your hands and turning on the light. That's the occupancy or presence based sensing. And compared that, it saves 21%. And this is one of the control parameters of 5 different offices. So as you can see, the very first 10 days, the control parameter fluctuating a lot, which means this reinforcement learning agent gives a lot of signals from the human agent because it has no prior knowledge about the people. So it keeps trying the new thing on turning on the light or turning off the light or turning on the light or turning off the light really almost randomly. So that's why it keeps fluctuating. But after that 10 days, it's somehow stabilized and it has a more steady value on those one of the control parameters, which means it somehow learns the rule. It somehow know how to play with against these people. But there's a one person, another playing after 30 days, so it gives that fluctuation again and gets the more standardized again. All right, so this is what I've prepared as part of ML algorithms. And I know I'm quite rushing on those some algorithms topics, but let me have your questions at this point about the ML algorithms. So here's a brief summary. We learn about three different classification. One is supervised learning, and second one is unsupervised learning, and third one is a reinforcement learning. The main difference between supervised learning and unsupervised learning is supervised learning, you have a label, and what you want to know is input and label and the mapping between the two. On the other hand, unsupervised learning, you just see the input and see the pattern and see the clusters and what is the rule behind it. That's more on the unsupervised learning. And reinforcement learning is the last example that I gave you. There's a decision-making process, and the system gives the somehow label, but dynamic label, like I answer to the Nair, and that is either positive reward or negative punishment. From the smart building agent point of view, if someone override your system, then that is a penalty term. So by interacting with the environment and agent, it is the same thing. Some for some fun photos from Boston Dynamics, like there's a robot keep moving and falling off, and then learn how to walk by just trying error on those failing the stuff. So by doing that, it will finally learn how to walk. So that is the beauty of reinforcement learning. And same thing in the smart building agent. It will do various kind of things and then identify what is the optimal rule for you or for the people to balance between energy consumption and the occupant comfort. All right. So again, these algorithms are not the full list. So have we talked about how the MDP algorithm was derived? So we're not really getting in too much detail on the MDP algorithm itself, but what is the MDP? And MDP is part of the reinforcement learning. So we're not really derive the MDP algorithm, but just like very gentle introduction at the MDP is the core foundation of the reinforcement learning. Okay, so think about the three categories and how those three categories can be applied into the built environment. That'll be the lessons you can take away from this module 2. All right, so let's have 15 or 17-minute break, and then we can resume our lecture in like 10:30. Okay, see you later. All right. Now it's 12. No, not 12. 10:30. So let's begin. Nikhil, can you see my screen and can you hear my voice?
Your voice is clear, but your screen is not shared.
Oh, okay. Sorry. How about now?
Yep. See this guy can see the screen.
All right. Cool. Thank you. So the last module of the ML part is really do some Python coding, which you learn from the day 1 or day 2, and then you wrapping up with this practice. So again, myself, June, and um, our lecture content 1, which was the yesterday one, was the introduction to ML. And lecture content 2, the previous one, I really super fast briefly talking about the supervised learning, unsupervised learning, reinforcement learning. And the point here is that I'm not expecting you learn these algorithm details, but I'm expecting what is different, supervised and unsupervised and reinforcement learning, and the big picture of ML algorithms. And lecture content 3, which is right now, we're going on, we'll use building energy data for learning classification algorithms, both KNN and decision tree. All right, let's work with data. So the objective for this coding practice is, can we classify the building location by their energy consumption pattern? So there are like, the energy consumption pattern is like our fingerprint. It shows how your building behaves. So from those energy consumption data, can you infer the building location? That's the main idea or main machine learning tasks that we're going to do. Okay. So the data set that I'm preparing here is the Department of Energy REX data. And you can just, download the data from the EIA.gov consumption residential, but I mean, there are periodically update these files. But the train set here is around 4,000 buildings and various energy consumption data and their location information. And there's a test set, which is a hidden, and the test set is 1,686 buildings. And again, same features and same target. So 26 feature here means like these are column header. So for example, electricity usage for space heating, main, secondary in kilowatt hours in 2015. Electricity usage for air conditioning, electricity usage for water heating, refrigerator, freezer cooking, microwave, clothing, lighting, television watch, and air handlers, ceiling fans, swimming pool, hot tub, and so on. So 26 different activities associated with the electricity consumption. And your classification target is either urban, urban cluster, or rural area. So 3 location information is 1, 2, 3. 1 is urban, 2 is urban cluster, and 3 is rural. So quick question. Is this classification problem or regression problem? Yeah, classification, because we are, it's a categorical value. Yes, it's a categorical value, either rural cluster, or the urban. And is it a supervised learning or unsupervised learning? Or reinforcement learning? Supervised, yes, because we have a label and we have input features, and we're trying to identify the mapping between input features energy consumption to the building location. So this is a supervised learning. All right. Now, let me stop sharing and then sharing again. Go to your MyGeoHub, and then if you check the Friday, May 31st, the ML activity will have ML Python complete, and you can choose ML Python, which is the MT Jupyter Notebook. Okay, I'll give you a few minutes to run this. Open the My ML Python, IPython notebook. Okay. Open ML Python dot IPython notebook. Everyone ready? Okay. So I just opened the ML Python complete so that you can type it the line. So the very first line is we need to import the basic libraries. So I guess you guys learned these libraries from the previous modules. So the very first two, import pandas as a PD, import numpy as NP, is the data structure related thing. So using pandas and numpy, you can work with the data file. And then import matplotlib pyplot as PLT, import Seaborn as SNS. Those two libraries will be used for the data visualization purpose, which you guys learned yesterday from the Dr. Aizuma's module. And import collection is something I'm going to use for collecting the information. So once you type these 5 lines, shift enter. Any errors so far? Everything good? Okay. And then number 2, now we need to read those train data set. So train data set here means this 4,000 buildings. So to do that, first data equal pd dot read slash csv parenthesis open and then data train dot csv. Type this and shift enter. This means you're now reading this data train dot csv as pandas data frame and you call it as data. Okay. So far, so good. Is there any error so far? Nikhil, please let me know if anyone type error, okay? No error? So now I'm going to do data.head, parenthesis open and close. What it means is I assign the data train.csv as a data, and I want to just quickly check how the data look like. So it's head of the points. So from 0 to 4, always Python, they start with the 0 index. 0 to 4, and 26 different features. And the last one was the location, the label. Okay. So all these kWh, SPH, kWh, COL is this: electricity and usage for space heating, air conditioning, and so on. And each row represents each building. And the first building is located in number 3, which is urban area. Everyone with me? Any error so far? Okay, then length, len, L-E-N, data is quickly check how many data points you have. And you expect 4,000 because that's the train data set. Okay. Everyone good? Okay. No error at all? Okay. Now, number 3 step. We need to split the data by feature and target, which is a label. So the feature is we're selecting the 26
Dr. Park,
different.
there is a comment.
Yes. Right. I can't load data train. Okay. James, did you type these? Data equal PD read CSV data train CSV? James? Okay. Is there the same problem? Different students? Also have that issue? Okay. So when you open this module, can you see these CSV files in your screen too?
Yes, they can see.
They can see? Huh, interesting. How about other students? Everyone has the same problem? Or did anyone answer, Nikhil? Or
No, I think only Dan, Christina, and yeah, they have same issues where they can't load the CSV file, and it seems. And I'm also logging in my MyGeo, and let me confirm back to you.
yeah. Thank you. So James, did you click this ml.ipython notebook on your MyGeoHub? Okay. Everyone has the same issue. Okay. Hmm. Did you have the same thing, Nikhil, on your end?
I can see all the files and the notebooks on the terminal. I
Okay.
just opened the
Yeah.
notebook. Give me a moment and I'll
Yep.
confirm back to you.
Yep. Yep. Yep.
Yep. So I ran the code,
Mm-hmm.
um, and it gives me the same error where it says that no such file directory. The error.
Okay.
So
That's interesting because I think all the files are loaded, as you can see,
one
but it
quick
cannot
question.
read. Yeah. Yeah.
So the ML underscore Python notebook is empty, right? And you're
Yeah.
asking them to write the code. Sorry,
Right.
just give me a second.
Okay. If that doesn't work, for the sake of time, I'll go over on my end, and then you can do it as an evening activity on these things. So all you need to do is download this two Jupyter Notebook files as well as the CSV files on your local machine, and then you can run this Jupyter Notebook on your local machine to the CSV files. That's one way to do it. Okay? But for the sake of time, I just do it by myself in the screen so that you guys can follow the instruction later on. But once we got the confirmation from Nikhil.
So yes, Dr. Park. So I tried them. I think the it's because of the MyGeoHub portal where you
Uh-huh.
have, I think, the read-only files and it doesn't allow you to load data directly.
Huh, okay.
So yeah,
So
if
yeah,
possible,
let,
you
let,
can, yeah.
yeah. So let's do it this way. So I'll do like my own stuff and sharing screen and share with you all. And then your side, once you're done with the module today, you can download this two Jupyter Notebook files and also the CSV files on your local machine, and then you run this codes in your local machine too, because all the codes are shared. Okay. So number two is, sorry about that. So sorry for all the technical issues. But that is what it is. Let's move on. So the read data is basically read this data train CSV into data file, and the head means just showing how it looked like. And I'm checking there's a 4,000 files. And now the next step is you need to split the data into by feature and the labels. So like I said, there is a 26 different features. So data iLock means, hey, let's just select the 26 columns and all the rows. So this first means all the rows and all the columns before 26. But it's including 0, so it's all 26. So if I click it, Shift Enter, then it gives me this. And then head, again, the checking. So here's a quick question. If I'm doing only select the 26 as a features, compared to this data file, what is the missing? What column head is missing compared to this data and this X? Nikhil, if someone type, please like tell me, okay?
Yes.
Anyone? What is the difference between this data and X?
So there's Alice who says X contains the data.
Yeah, X contains the data, but it only contains the column until 26. So that means it only contains the data until KWHNEC. So if I scroll this data to the end, there's no location data, right? This is a feature that you want to learn, okay? So if I select like 5, then your data look like your X look like this. You're only selecting first 5 columns. And if you want to have like 10, then you can have just 10 first columns, right? And what if you want to only get KWHMICRO and KWHCW? What number we should put in here? Let's say you only want to the last 2 columns in here. What number you should put here?
Christina says 9. She's asking 9.
Yeah, almost. 8. The answer is 8 because it starts from the 8, 9, and 10 is exclusive. So 8th. But it was close. Good job. So this iLock function gives you like play around like what feature you can select. So let's go back to 26. So now we're just selecting the raw data, raw features of the 26. Then Y is your location, which is your label. So data.location and Y head. Then you got 3111111, and that is this one, your location value on each building. Okay. And collections.counter Y is basically count the specific values in your data frame. So if you click it, then 3 will be 805 urban buildings, 2090 Is it right? Or let me check, double check it. So one was urban. Sorry, one was urban. So urban is 2,759 urban building, 436 urban cluster building, and 805 rural buildings. That's our 4,000 data set look like. Okay. Any questions so far? Everyone good? Now, we need to train the KNN and decision tree model. So for that, we need to import the new library from the scikit-learn. So this is sklearn, which is a scikit-learn, and import tree model and import neighbor model. So if you Google scikit-learn, and there's a one website, scikit-learn.org. If you click it, this is a machine learning library for all the utilizing in Python. So as you can see, classification, regression model, clustering model, which is part of unsupervised learning, model selection, dimension reduction, pre-processing, and all the machine learning techniques, then you can use as a library. So if I click the classification, then there are a lot of models that you can select based on the supervised learning model. So support vector machine, nearest neighborhood, which we're going to do, naive Bayes, decision tree, which is we're going to do. And another way of learning the new algorithms, ML algorithm, is just checking these the resources scikit-learn that you can provide. For example, I want to know support vector machine. Just click support vector machine and read it. Their explanation is quite like informative. So SVM are a set of supervised learning method used for classification, regression, and outlier detection. Their advantage is effective in a high-dimensional space. It's effective in cases where number of dimensions is greater than the number of samples, and so on. And they're classification-based. So if you can, from sklearn, import SVM, and you have import X and Y, then you can learn your support vector machine file. Okay, so this is one way of learning the machine learning too, if you're interested in utilizing Python. Let's go back here. So in our example, we want to train the decision tree model and KNN model. So if I shift enter, so this means A, calling the scikit-learn and import the tree model and import the neighbors model. And the model one is tree dot decision tree classifier. So let me show you one thing. If I type model one, so I'm calling this model one as my decision tree model. Tree dot, and if I tap key here, you can see all the tree models that I can choose under this tree library or tree like function. So from here, I want a decision tree classifier. And parenthesis open, parenthesis close means just read or let's run this model. And model two is I want to do neighbors KNN model. So neighbors dot press tab key, and then you can select the K neighbor classifier. Parenthesis open, parenthesis close, shift enter. Now you are loading tree model in model one and neighbors model in model two. And then you can fit those model by XY dataset. So you can do shift enter here. So it means you are feeding your X features, Y labels in model 1 and model 2. The model 1, which was a tree decision trees, and model 2, which was neighbors, KNN algorithm. Okay, so it is a step for train the model. Any question at this point? Train KNN and decision tree model. Everyone good? So next step, we need to choose what K number we should choose to balance between overfitting and underfitting problem. So for the overfitting and underfitting problem, what technique did I introduce to you yesterday and today? Can anyone answer? What is a technique we can choose to avoid the overfitting and underfitting? So here's a hint. We need to validate this, and this is called split and repeat. What was that?
Christina says cross-validate.
Yes, yay, cross-validation, right.
Lorraine also says the same.
Yep, all right. So cross-validate, you remember the last lecture? So ML introduction, let me recap. The cross-validation was you select a certain portion and then keep split and repeat, split and repeat. You're training on a different set and test on different set. And tenfold or fivefold cross-validation means we repeat these things 5 times in a randomized split models and then take an average number so that you are more conservative so that you can choose more conservative model to report your results. Okay. So the scikit model selection literally do that cross validation for you. So you don't need to coding the randomized thing, but just read this module from scikit-learn model selection, import the cross validate. And now model 1 CV, model 1's cross validation is cross validate, which you just read, and then model 1 X, which is a feature, Y, which is your label, and scoring. This is one of the scoring method. And cross validation, fivefold cross validation. And this is just like the reason for the printing, no printing issue. And model 2, which is your KNN, K-nearest classification model. Model 2, X, Y, scoring CV equal 5. So if I shift enter, and it runs that fivefold. So let's do tenfold. You can increase the tenfold, so it's more longer time, but it's still quite immediate. So your model 1 CV, how many scores, accuracy scores in the model 1 CV? How many accuracy score will get in model 1 CV? Can anyone guess?
3.
3? Why 3? Any other number? So let me repeat this. So this is a like k equal 5 cross validation. So I split the data set into 300 and 700 for 5 times in a different mode, and then get the results on each split. And this is 5-fold cross validation. So how many accuracy score did I get? 1, 2, 3, 4, 5. Each split, I can get the numbers. And I got the average score of these 5-fold cross validation. Right?
So Pooja
How
says
about
5.
hmm?
Pooja says 5.
Yeah. So now in our case, in our coding example, so literally this coding example is making all my like explanation into the coding practice. So I put 10 cross validation on my model 1 feeding my data XY. So how many scores will I have in this model 1 CV? Now this is a 10-fold cross validation. How many scores?
10.
10, yes. Let's check. 1 CV. So it's a fit time took. So every cross validation, it took 0 0.06, 0 0.06, 0 0.07, quite immediate, and score time and test score. So here, the first split, like this one, the first split, it gets the 0.4. The second one, 0.45. Third one, 0.41, 0.41, 0.41, 0.39, 0.40, 0.41, 0.38, 0.35, 0.38. So these are 10 different scores, 10 different fit time, 10 different score time. Okay? Got it? Now, model 1, CV. Now, my job is, what is the average score of these 10 cross-validation score? So to make it, just numpy min of model 1, CV, and test score. So it basically returns the decision tree model's test score average. KNN model test score average. Let me open model to CV. So the average score of 10 cross-validation on the decision tree model was 0.48, which is around 40%. And KNN was 0.43, so which is around 43%. So without any tuning, just doing this like model training, default setting, the KNN is slightly better than decision tree, but their thing is not really working well. It's less than 50% accuracy. So that means we need to tune these models. For the tuning purpose, I'm introducing grid search. And grid search means you are basically giving all the possible combinations that you can choose in a parameter selection. So in KNN, let's go to here. you need to specify what K number you can choose for better accuracy. And here, if I do scikit-learn model selection grid search CV, and then neighbors from 1 to 1001 every 10 steps. So let me show you. So this means you're just showing from 1, 11, 21, 31, 41 until 1001. And then you're doing, because it's a K nearest neighborhood, model 2 loading, and the parameter selection, which is from 1 to 1001, and cross validation of 5, and scoring method, same as a precision macro, and return false, train score false, so just for the printing issue, and then fit that model with X and Y. So let me run. It will take some time because it is really searching all the possible combinations of K nearest neighborhood options. But what it does is really on your model 2, which is your like baseline KNN model, change that K number from 1 to 1001 every 10 incremental, and then check the cross validation score of 5 cross validation, and then put that into the using your XY data set and see the result. Any questions so far? Because it's, yeah. Are you going to say something? Nikhil, did you get any?
No questions here, Doctor.
Okay. So let me repeat because it's anyway running. So the grid search in summary is, like I introduced in the previous section, KNN algorithm is you have to specify the K number, either 1, 5, 6, 7, 8, 9, 10, 11, 12, until whatever number that you have. And K equal 50. So, oops, not this one, not this one. So what I did is basically in grid search, my model 2, which is a KNN, from parameter choice from 1 to 1001, run the cross validation of 5 for each case and show me the result or get the result. So now it's done. It took some time. Show me the grid search result on parameters. So the K number selection is from 1, 11, 21, 31, 41, 51 until 991. That's what we tested out. And the mean test score gives us, for example, if K equal 1, then the score is 39%. And if K equal 11, then 42. K equal 21, 41. 39, 39. Keep increasing these numbers. And we can make a scatter plot out of it. So the x-axis shows the K number from 1, 11, 21, 31 until 991. And then Y value, Y-axis shows the accuracy values. So the general trend is like one very spiky value in here, but keep slightly increasing, and the max is around here, around 400, and the dropping. So once it goes to around 400 something, then it drops the accuracy. So no need to actually rerun the after the 400 something. So there is a one thing, you have a model to GS, and you can put the best parameters out of it. So if I click it, then it shows the best parameter score number you get is the K equal 391. And best score, what the best score was, 44%. So it's slightly increased, not significantly. And now the best estimator is, if you select 391, then that's the best way you can do it out of those your given data set. Okay? Any questions so far? All right. So what if no, never mind. So this is all about the training data set. So here, about this one, 4,000 building. Now our job is, we learned that 391 K nearest neighborhood is the best thing we can get. So we need to, that's the whatever I learned from this 4,000 building data set. We need to test it out on these 1,686, which is a hidden data set. So for that, I need to, again, read this data set first. So test equal pd.read.csv data test.csv, basically reading these things. And then test head. Again, it shows all the 1,600 data set of the hidden testing data set. The length, oops, the length will be 1,686. Again, iLoc and location, and report your results. Now you are basically assigning your test set in here. You need to report your result in here. To the report, there's accuracy score and confusion matrix. Confusion matrix is, just for a recap, that orange and lime problem. What is a true positive? What is a true negative? False positive and false negative. Then you can get the accurate score out of it. So you can read the scikit-learn.metrics, import accuracy score, scikit-learn.metrics, import the confusion matrix. Click it. And then the prediction model one is the model one, which was your original decision tree, the very first one, the worst case scenario. And prediction number two is the best one, which is by model two, K nearest neighborhood, result by grid search. So this means you put X test, which is a hidden data set, feed into your original model one, which is a decision tree, the worst case scenario, and your model two grid search, which is your best scenario. The original decision tree score was, in fact, get around 59% accuracy. So it's slightly increased on this test data set. And if you draw the confusion matrix, then it gives this one. So what it means is 859 buildings are correctly classified as urban buildings. 24 urban cluster buildings are correctly classified. 125 rural buildings are correctly classified. So these diagonal elements are correctly classified buildings. Now we're doing the tuned model. The accuracy score is 69. It's a lot of improvement. So about the 70%. Again, we can draw the confusion matrix. And the confusion matrix is quite interesting because there are 1,150 buildings quite well in the urban area, but 0 on the urban cluster, and 22 rural buildings. So that means there's in this data set, there is actually no urban cluster buildings at all in this data set. So, which means our very first test and training splitting was not stratified well or randomized well. But anyway, gives us some improvements by this KNN parameter tuning. Any question? All right. So let me change the settings a little differently. Our original selection was 26 like features. But what if we are only focusing on like 15 features? So you can change now, you're only selecting 15 different 15 different features that you want to feature out. And the location is the same. And everything is the same, but just we are selecting 15 features. In fact, the decision tree goes down and KNN goes up. And we're doing grid search because it will take some time. So what does that mean? Going back to the ML algorithm section, in KNN algorithm, if we increase the dimensions, then the distance calculation is very, very, very far away, which is not very informative. So the very first point here is for a higher dimensional space, the KNN would not work well, right? So we reduce from 26 to 15. So it gives slightly increasing just by cutting the information out. On the other hand, decision tree, all these features are, feature information is important. So I remove some like features of energy consumption information. So their accuracy is decreasing, right? So depending upon your choice of algorithm, you need to choose a different feature engineering technique or feature selection techniques. Maybe grid search is done. Yeah. 1. 11. Let's see how this 11 performs better than the 391. You need to change the number into 15. Now 58, which was the original one. Now 69. Not so much difference it's the almost same number that we can, this is 11, that we can get. But anyway, um, this whole like procedure is very, very, very generic procedure that any of your machine learning task you could follow. So if you have your own data set, then you can change your CSV file here, and then you can try out different algorithm in this algorithm selection in number 4, and you can change the cross-validation numbers in number 5, and then you can tune your parameters in using the grid search. And you can test the model on your hidden data set, and you can report by confusion matrix. That's the procedure that you can adopt for any type of the data that you have. Any question? And feel free to check out the scikit-learn, the directory that you can learn. Sorry again for these technical issues, but all the codes that I demonstrated today is uploaded in the MyGeoHub. So you can download all these files in your local machine and you run it. So coding practice, and also all the codes are written in here, so you can check it out here too. So the last piece today is the evening activity. This one, oops, cancel. Evening activity. So this is an evening activity for today, and the main idea is machine learning, and the objective is students will explore one of the famous building energy consumption prediction competition from Kaggle, hosted by ASHRAE, American Society of Heating and Refrigeration and Air Conditioning Engineers. Students will self-learn how the leaderboard solution by the reading their posts and identify potential involvement of machine learning competition. So steps, it's quite simple. Go to ASHRAE Great Energy Predictor 3 competition page. Here's the link. And read overview and data tab to understand. So this is a Kaggle, and Kaggle is kind of platform that everyone can do the competition out of it. And ASHRAE, the organization from the building engineers, they create this type of competition back in 2019. And they basically unload all the data about the building energy and, hey, this is the data that we have. Can you propose your prediction algorithm of the energy consumption? And the winners will get this prize money, 25K. So they are really doing this for business, like, just getting the money by showing off their knowledges. So go back to this one. Read overview and data tab to understand the background of competition I just explained, and access to the leaderboard tab to understand how they won the competition. Questions. What was the objective of competition? Explain the metadata information of building data. What was the metric in the competition? Pick one leader group board, rank 1 to 5, and explain their feature engineering strategy and prediction algorithm selection. What would be your strategy if you want to win this competition? And check out any other live competition, water and energy related Kaggle competition, and explain your selection. So if you go to leaderboard, it's already done in 2019. The leaderboard got like score of 1.2, and they even upload their solutions. If you click solution, then they explain how they won the competition. So read this, then see how they won the game. And if you go to just Kaggle, then this is the largest ML community. Then you can see all the competitions, the live competition that you can do. active competition, like what would be the good image matching, atmospheric physics, regression with the flood prediction, which is water related, house price competition, natural language processing competition. So these are ongoing, and it'll be fun to if you can like participate that. And that's all about it, including the evening activity. So I'm actually done now. So Dr. Eisma, do you want to take it over?
I can do that. Thanks, Dr. Park.
Thank you.
Yeah, so, all right, folks, this is the end. You've survived. We've all survived to get here to this point. I do have a brief closing presentation just so that I can keep myself organized. This is mostly going to be things that you should more or less already know, but in case you don't, we have this here. Let me actually start presenter mode. Okay, so this is just first going to remind you of what the Justice and Data Fellowship requirements are in case you are planning to take advantage of that opportunity. So hopefully you already completed the 2 pre-surveys before the bootcamp began. And if you were in attendance for about 80% of the bootcamp lectures, not counting excused absences, which I know there were a handful of them due to extenuating circumstances, you'll also be eligible for the fellowship funds, and then also you need to complete 2 post surveys. One of these post surveys is a concept-based post test. One is more an experience-based post test. So for neither of these are, in any way, shape, or form going to influence any score or grade. They're just for our own information. The concept-based post test is going to concept-based post test will tell us how well we were able to actually convey what we wanted to convey and what you were able to learn from this bootcamp. The experience-based post test is more centered around self-efficacy and your confidence in these concepts and in using data science skills in your own research and your own work. And also we'll ask you questions about, to understand what worked well and what didn't work well for you, kind of in regards to the bootcamp structure and content altogether. And then we have a third sort of post survey, which is actually our summer registration form that we ask you to fill out. This is just for you to indicate whether or not you're interested in participating in the summer program, and so that we can kind of organize that and get it started. So once all of these are complete, we will disperse the first portion of the fellowship funds, which I think, if I remember, is $350. I have it pulled up here. I can verify that. Yeah, $350 for the first amount, if we are able to successfully complete these. Oh, just another reminder, we want to have the bootcamp surveys done by Monday, June 3rd at 5 p.m. Central. So that gives you more or less 3 days to get these done. This is just for our purposes. We don't want it hanging too much. We'd like to get it tied up and get the funds dispersed as quickly as possible. So we also have the second portion, that second $225 available if you choose to participate over the summer. So the summer Justice and Data summer program involves mentoring meetings. These mentoring meetings will take place every other week. They'll be for 1 hour, and it's going to be a mentoring circle type format. So you'll be put into groups based on maybe your availability for meetings, which you'll indicate on the summer registration form, and or your interest in certain topics, right? So if you're really interested in water and groundwater analysis or something, and there's 4 of you and you're all available kind of at generally the same times, you might be in a mentoring circle together. So the mentoring circles will be, I would say probably about 5 students. And then also you'll meet with 2 of the bootcamp instructors every other week during the summer. And these mentoring circles are somewhat flexible. The point of them is to provide you with repeated contact with somebody who can maybe help you with data science questions, help you with questions related to the content that you learned here that you are trying to apply in your summer research if you are conducting summer research. And then also we're able to answer questions more broadly about research or research careers or graduate school if that's something that you're thinking about applying to or are interested in learning more about. So these summer mentoring circles are somewhat informal conversational spaces for you to learn the content better, to learn the content in a different way, and then also to connect with your peers in a different way than what you were able to over the course of the boot camp. And then at the end of the summer, we have the Summer Research Symposium, which is an online format. Depending on the number of participants who choose to elect, we might have a couple different tracks to organize this, but this is just an opportunity for you to make a approximately 5-minute poster presentation, scientific poster presentation on the summer research that you conducted. And then with the hope that you highlight and focus on how you applied some of the concepts that you learned in the boot camp to your summer research. And we just want to highlight or make it known that you don't have to necessarily have a paid summer research internship in order to participate in the summer research symposium. There's been instances in the past where someone was interested in conducting research but didn't have a paid position. So they were able to work with their summer mentors to identify a data set that they were interested in analyzing, come up with a research question, and do some independent analysis on that. And then at the end of the summer, it's just a 5-minute presentation. So it's nothing too, I would say that it's nothing too intense that you have to have done, 400 hours of research or something in order to be successful in presenting at that summer research symposium. So that is the 2 major components of the summer research symposium. We do have support from the MyGeoHub folks to actually have you develop a portion of your research workflow into a tool. So MyGeoHub publishes with a nice graphical user interface research workflow tools that will help other researchers conduct a portion of their research using your tool. So if that's something that you're interested in, developing and publishing a tool that others can use, we can also work on that over the summer and collaborate with the folks at MyGeoHub to make that happen. So that's not required for actually receiving the bootcamp, the second half of the Justice and Data Fellowship funds, but it is an option if you are interested in that. Okay, so questions on what the summer program entails. We're talking about bi-weekly 1-hour summer mentoring circles, and then also largely talking about the end of summer research symposium, which usually happens on a Friday in August. But we haven't set that date yet. Okay, so in order to receive the second half of the Justice and Data Fellowship, you need to attend 60% of your summer mentoring circle meetings, and then also participate in the summer research symposium by presenting a poster. And once those are complete, you would receive the second disbursement. You also, I guess the third note, which isn't listed on here, you have to have participated in the bootcamp successfully by achieving the list here in order to be eligible to receive the funds second time around. Okay. Questions on any of that related to the fellowship funds and kind of what needs to be done? No? Okay. So you should have received an email from Kayla and Gassam from PaymentWorks in order to be registered to conduct the paperwork for direct deposit of your fellowship funds. I know it looks a little bit funny because you're technically set up as a vendor if you are external to UTA, but that is a requirement in order for us to actually set you up for receiving these funds in your bank account. If you are a UTA student and you have been employed by UTA in any capacity in the last year, you won't receive a PaymentWorks. They'll pay you through the direct deposit that they still have on file from when you were employed by UTA. So definitely look for this PaymentWorks email. If you haven't already done so, make sure you get that filled out so that you can receive the funds in your bank account. If you can't find the PaymentWorks email, let me know, send me an email, and then I will also check with Kayla to see who has not yet finished filling out their PaymentWorks information so that we can send you a reminder email to get that taken care of. Because yeah, this is a part of the program, and it's important for us to make sure that you receive these funds as soon as possible if it is something where you were able to successfully complete the requirements. Okay. I guess before we carry on, any questions on the Justice and Data Fellowship program, the summer program, making sure that you are able to get paid from it and receive the stipend? No, okay. Like I said, send me an email if you need to, if you have any questions on any of this. Okay, so as an additional opportunity, we do have external evaluators. Okay, so I do have a question in the chat from Henry, and Henry says, if we haven't filled it out as of now, is it still valid to fill it out? So I'm going to assume you're talking about the PaymentWorks documentation, and if you haven't filled it out, yes, you should still be able to fill it out. And if your links are expired or not working, let us know and we can resend them to you. But we sent them to you 2 weeks ago just to try to get this process underway and get as many students taken care of as soon as possible. But if you do it today, tomorrow, in 3 days, we'll keep a track of it and make sure that you do get your funds. So yes, if you're having trouble finding the PaymentWorks, if the links aren't working for you for some reason, let us know. We'll get that taken care of. Okay. So any more questions on that? No. Okay. So we do have external evaluators hired to help us, or contracted to help us with this program, and they are independent evaluators. They don't share any information you share with us other than like in a broad, big picture type of way. None of the information they share is tied to you as an individual, but they are, as part of the evaluation process, conducting about 30-minute semi-structured interviews with Rosa Acevedo. She is the lead for the external evaluation team, and these interviews are just an opportunity for you to have a free-form way to provide feedback to us that maybe wasn't covered in the any of the surveys that you filled out at the end. And they'll usually just use these to provide us with an outline of what worked really well, what didn't work well, and then provide recommendations for how we can improve it for the next iteration of the bootcamp. And as a part of this, we're able this year to offer an additional $50 incentive payment that would be sent to your same direct deposit as you send, or as where you would be receiving your Justice and Data Fellowship stipend. So we can also disperse that. However, just because of limited funds and also Rosa's limited time, we're only able to offer this $50 incentive payment to the first 10 bootcamp participants who choose to sign up for this opportunity and schedule an interview. So Rosa is planning to send an email out to all of the bootcamp participants on Monday. So if you are interested, definitely take a look at that. Her email is, I was going to put it on here and I forgot, is rosa.acevedo@uta.edu. So she will be sending it from a uta.edu email address. Okay. Questions on the semi-structured interview? Does it make sense? Yeah. Okay. By semi-structured, it just means that she has a list of questions she will ask, but there's no need to get through all of the questions, and you'll be free to extend the conversation in one area if you want, or to go on a tangent to talk about something that's relevant to the boot camp if you want. That's what we mean by semi-structured. Okay. So the last but not least, we have uploaded on MyGeoHub, which I can show you. End of bootcamp tasks. We have links here for each of the required exit forms. You should be able to click on them. Oh, I'm not logged in to MyGeoHub anymore, apparently. Let's see. Okay, required exit forms. You should be able to click on these and have them all pop up where you can go through and do these 3 summer or end of bootcamp forms. They're also available on here, and I can put them in the chat if that is helpful to you as well. So you have a few days to do these, but if you have the time now, we highly encourage you to take care of them now. Any questions on these things?
How long should the test and the survey take to complete?
So the experience-based post survey, that is the external evaluators, I think they listed about 10 minutes for you to do it. And then the content-based post test, it's the same questions as what you took with the pre-test, which is I think 39 questions. They're multiple choice questions. So that one, depending on how quick you are, how fast of a test taker you are, that might take you, I would say up to an hour, but maybe only, half an hour, 45 minutes, depending on how quick you are at those multiple choice tests.
Okay, thank you.
Yeah, you're welcome. In the summer program registration form will probably take you like 5 minutes. It's mostly just clicking and a little bit of your typing in your availability. Any other questions? No? Okay. So my plan right now is I'll put these links into the chat if that makes it easier for you to access them, as opposed to going to my GeoHub. And then also I'll stick around here until about 12:45 or so. If you have any questions, if you're having any difficulties with any of this, I'll stick around and you can ask me. So without further ado, thank you so much for taking the time to participate in this bootcamp. We really hope that it was a positive learning experience for you, that it was interesting to you, and that you learned a little bit more about how you can leverage Python in myriad ways in order to enrich your research experience, what you're able to do with your summer research, or any programs that you research type programs that you're engaging with this summer. So thanks, folks. And I hope you have a great rest of your summer. And I'll see you around if you choose to stay engaged with the program over the summer.
Thank you.
Yeah, thanks, folks.
Thank you.
Bye.
Thank you.
Thank you.
Yeah, thanks.
Thank you so much.